Okay, welcome back to another series on Whiteboard. Now, today we are going to look at the chapter on matter. Now, matter is a very abstract topic, which means that it's something that requires you to imagine, okay, in your brain what exactly is happening. A lot of things can only be explained via experiments or models. A lot of these things that's got to do with matter is basically happening at a microscopic level, too small for us to even see, okay? So the first thing that I really want to talk about is what exactly is a matter. Now, you need to basically know this by heart, okay? Now, in order for something to be considered a matter, you need to understand that it must fulfill two very important criteria. Okay, so let's take a look at what it is. Yes, very good. Okay. So the first thing we need to understand is that matter is anything, okay, that has mass and occupies space. Now, we are going to look at what is mass and what you mean by space, okay, in detail. So the first thing we need to understand is that all matter have a mass, okay? So we need to actually know what exactly is mass and how do you actually compare. Now, in order to find out what is a mass of something, you need to use a balance, okay? A balance is something like, a very simple one would be, you have a plank of wood and then you have a pivot, okay, something like a triangle, okay? And you have the object sitting on one side here and another side here. So the heavier one will always go down and the lighter one will always go up. So we call this a balance. Now, of course, this is, in the ancient day, we use this in the most simpler form to compare the masses of different objects to see which one has a greater mass. Alright? However, in modern day, we don't use this that often anymore. We use something called the electric balance. So the electronic balance, right, basically, or the digital balance, basically gives us the mass of various objects very accurately, alright, in numbers.
How?
Okay, so when will we use this electric balance? So for example, if let's just say you are trying to bake a cake, you need to know what is the different mass of the different ingredients. You would use an electric balance to find out how much flour do you need, how much sugar, alright, in accordance with the recipe.
Now?
Okay? So basically, something with a bigger mass will always tilt the balance down. So we say that this one, A has a bigger mass as compared to B. Now, I also want to caution, okay, whenever you're comparing, the words that you use, right, needs to be bigger and smaller, okay? If you're comparing between two items, please use the comparative form, okay, of the noun. So, what exactly is mass? Alright, so mass is basically the amount of matter in an object. Okay, so I'm just going to put it here for you. What is mass? Question mark. is the amount of matter in an object. Now, what do I mean by that? So, I want you to imagine now that you've got two different blocks. Alright? Two blocks. They are the exact same size. Now, the first block over here, let's just say it is made up of concrete. And the second one over here is made up of plastic. Now, if you were to put them on a weighing scale, you would realize that the concrete will go down. Yes, very good. Okay, it will go down because your concrete has a bigger mass when you compare to your plastic block. However, they are the exact same volume. The amount of space that they occupy is exactly the same. So what it means is that when you actually zoom in, alright, so remember I told you that it is the amount of matter in it, right? So maybe the matter that is forming the plastic is a lot looser packed. So you pack lesser amount of matter in it as compared to your concrete, where the matter that is using to form your block is packed very, very tightly. Really, very tightly. Okay? Such that you can squeeze in more matter into the same amount of volume or same amount of space. Alright, so this actually follows the definition whereby we say that an object with a bigger mass has more amount of matter in it. In this case, it will be this block over here.
Concrete?
Yes, concrete. So we say that the concrete block has a bigger mass, which means that it also contains more matter. Now, remember when you use the word more matter, you have to compare it to something. So in this case, we are comparing it with the plastic brick.
Mr. Chong, but then the plastic is bigger than the concrete block. But how the concrete is bigger? How come the concrete is smaller than the plastic block?
It's the same. It's just that the method, the way they pack it. Alright? Certain matter can be packed very, very tightly compared to certain other matter. That's a good question. Now, moving on, I would like to actually introduce to you this idea of mass versus weight. Now, I want to actually stress that these two are actually not the same. Okay? Now, your mass over here talks about amount of matter that makes up this particular object, whereas the weight talks about the gravity or the gravitational pull, okay, on the object. So for example, if you have an item, alright, let's just say you have a delicious hamburger, and this hamburger, the mass of it is actually 300 grams. Okay, by the way, mass is measured in grams and kilograms. When you it weighs, the mass of this burger is 300 grams on Earth. Now, if you were to put the burger in a rocket and fly off to the moon, the very same burger will still be at 300 grams on the moon. There is no difference. Your mass does not change at all because it is the amount of matter that makes up the burger. So it doesn't mean that just because now that I've gone to the moon, there's lesser amount of matter making me up. So can you imagine if that was to be true, if you go to the moon and your burger becomes less mass, it means that part of the burger will actually need to be gone. Which is not true, right? Okay, your burger is still a burger as it is. Alright, the mass is exactly the same at 300 grams. Now, what happens is that on the moon, your gravity is different. So therefore, your weight changes, and that is the difference. Okay? So there is a lot of confusion whereby, people always ask, oh, what is your weight? What is your weight? Actually, what they're asking for is, what is your mass? Because weight changes, alright, with location due to the different gravitational pull. Now, so this is something that's very abstract. You're going to have to imagine it. So we're not going to dwell too much on it. Okay? So, next, let's talk about the concept of space. Not the outer space that we are talking about. I am talking about the space whereby you are able to put things. Okay? Now, the first thing we need to know is that all object takes up space. Okay? Now, this space that we are familiar with, there is a scientific term to describe it. Now, the scientific term to describe space is actually volume. So this word is very important. So volume is basically the amount of space that is taken up by a certain object, and that is called volume. So the next thing we have to understand is that the space that is taken up by something cannot be taken up by another thing. Okay? So the space that is occupied by an object cannot be taken up by another object. Okay, so once it's being taken up by something, right, you cannot just say, okay, I'm going to squeeze something else inside there. No, it doesn't happen like that. Alright? So we also have to understand, okay, at this juncture, I think it's very good to let us recap on what is a matter. So the first thing we need to understand is that a matter, in order to be a matter, you have to fulfill two different things. The first thing is about occupying space. And the second thing that you need to know is about having a mass. So only when a certain item fulfills these two criteria, only then can you say that it is actually a matter. So let's do some examples over here. So for example, if you have shadow.
Shadow is not metal.
So you need to ask yourself, does a shadow take up mass or space? No, it doesn't.
Just take out
Okay, so is it a matter? Yeah, we would think that it is not a matter.
That is also no.
What about love?
No.
Yeah, love also doesn't take up space or mass, so it is not a matter. What about your glasses?
How about happiness?
Okay,
No.
it takes up space, right?
Yes.
It also has a mass, so we say it is a matter.
Mr. Tom.
Okay, and what about, let's see, how about air? Okay, now, do you think air takes up space?
Yes.
Very good. So yes, space actually takes up air. Does it have a mass?
Yes.
So it is a matter. Now, this is a very common misconception.
Air is metal.
Now, many students think that air is not a matter simply because air cannot be seen. Alright, they think it's invisible, so it doesn't occupy space. Now, there is a very simple experiment to prove this. Alright, so I'm going to explain the experiment to you. Now, the experiment is very simple. So basically, you have a balance. Now, on one side, you will fill balloon A, and on the other side, you will fill balloon B. And what you realize that if you fill them up to the same size, you realize that the balance does not tilt downwards or upwards. However, if you were to take a pin, okay, and you poke it, so let's say you poke balloon B, and what would happen is that balloon B will actually have a hole, and you realize that it starts to shrink to become very small.
No, but then when you use a pin and the balloon, you pop easily, just pop or you just explode.
Okay, it will shrivel up. And not only that, you will also realize that balloon A would then go downwards. Now the reason, alright, for this is because air has mass. So what happens is that when you poke balloon B, you're allowing all the gas to escape from the balloon. Okay, so now balloon A becomes heavier, it has a greater mass than balloon B because all the matter, in this case it's air, has escaped from balloon B. And since A still has its matter in it, it actually has a greater mass than balloon B. On top of that, this experiment also shows you that the air actually occupies space. The only reason why your balloon was able to inflate, okay, to become bigger, was because we filled it up with air. And this air actually stretches your balloon and cause it to become bigger. Alright? Now, the next thing I want to talk about is actually the 3 states of matter. So I'm sure many of you are pretty familiar with this concept, but I will just talk about it. Now, the first one that we have is actually solid. And then the next one that we have is liquid. Followed by the last one, which is gas. Now these are the 3 states of matter. Now what do I mean by that? So basically, your object can exist in 3 different states. Now a very good example to help us visualize, okay, and make sense of it would be your water. Okay, water has 3 states. Now the very first state that it can exist in as a solid would be your ice cube. Okay, so this is where you've got solid. Now dry ice is something that is different, okay, which I will talk about if I have time in another tutorial.
When is solid, it became gas.
Then after that,
They'll melt.
it can also become a liquid. Okay, when it actually melts. Very good. And then after that, the last one is actually it becomes
Gas.
okay, a gas known as water vapor. So your water vapor is basically the gas form of your water. So this happens when it evaporates. Okay? Yeah. So that's why sometimes when you spill water on the floor, you notice that, hey, after some time, the water disappears. It's no longer wet anymore. And the reason behind it is because the water has actually evaporated into the surrounding air. So these are the three states that water can exist in: solid, liquid water, as well as your gas. Now each of these states can actually have their own property. Now it is important that I'm only using water here as an example because it is something that we are very familiar with, because we all have seen water, liquid water before. We all have also seen solid water in the form of ice. Okay? So what happens here is you need to understand that almost all substances or most substances is able to exist in these three forms. Meaning that if you have a piece of gold bar, literally the metal gold, the precious metal gold bar, if you heat it up to its melting point, the temperature at which it will melt, it will become a liquid form, and that is in the thousands of degrees Celsius. Okay, so I just want to make it clear why we are using water here, because many students have this problem of thinking that, hey, you know, only water has these three states, when it's actually not true. Okay, many other materials can exist in these three states as well. Okay, so how are the particles, all right, how do they look like, all right, under, let's just say we have a special microscope and we're able to zoom all the way in, okay, to take a look at them. Now this is solid, liquid, and your gas. So let's just say we have a special microscope and we're able to see how the substance, the matter that makes up this object looks like in its different state. Alright, this is how it will look like, literally. Okay, so we have, let's use water as an example. So when water is an ice cube, okay, how does it look like when we zoom into the substance that makes up your solid ice cube? Now all the particles are actually very, very, very tightly packed together in a very orderly manner. Okay, so they look like this under a very special, powerful microscope. Everything is packed very, very, very tightly. Okay, very tightly. So there is actually very, very little space. Okay, if you were to zoom in and you see, there's actually very little space in between all the particles. Okay, and then let's compare to liquid. Now for liquid, the particles, they are not as tightly packed as your solid. Okay, so they have a bit more space, but they are still closely packed together and they are not in an orderly manner. Okay, these particles that makes up your liquid. And then finally we have your gas stage. Now in gas stage, I want you to take note that the particles are very far apart from each other. So can you see that the distance between the particles are actually very far apart, okay, as compared to solid, whereby the particles are very close together. There's no more space for solid. However, for gas, right, you see there's so much space in between particle A and particle B. Okay, and there is a reason why I am pointing this out to you. It is very important. Okay. Now, you need to understand that for solid, okay, it's got a definite shape. Okay. Now you need to actually know how to spell this word, definite shape, meaning that the shape cannot change. So for example, if you were to put a cube, okay, that's made of plastic into a round cylindrical bowl, it would not change in any way. Okay? However, if you were to actually put liquid into a cylindrical bowl, your liquid will actually take the shape of the bowl. Okay? Now, you also need to know that your solid cannot be compressed. So when that is the case, we say that it's got a definite volume. Okay, remember, let's recap. Volume is the amount of space it occupies. So because the amount of space a solid occupies is fixed, we say that it cannot be compressed. Okay, it cannot be made smaller. And the reason is because if you were to look into it, okay, I'm going to highlight to you once again, the distance over here between particles, say this is particle A and particle B, is so small. There is no space, no matter how you squeeze the particles together, right? They cannot get any closer. There's just not much empty space. Okay? And if you were to compare to the gas, alright, so this is the distance, you see that there's a lot of empty space between particle A and B. So when you were to exert pressure and try to squeeze the object, these particles can actually go closer together, okay, causing your original volume of air to decrease. And we say that the air can be compressed. And this is why for gas, we say that it does not have a definite shape. It also does not have a definite volume. So meaning that its shape can change, so can its volume. So if we take a look at the particles that makes up this gas state, right? All the particles are just randomly moving around. So I want you to imagine if you have a classroom, okay? In a gaseous state, there will be about only 5 students in your classroom, and they are actually just moving around randomly. Okay, that is how gas particles, alright, react. Now, what about liquid? So for liquid, we say that it's got no definite shape, meaning that the particles can move around, alright, and it will take the shape of any container. However, it has a definite volume. Okay, so what does it mean? Why? Because even though the particles are actually arranged quite close to each other with some space, the space in between each particle, alright, is still not enough. You still cannot squeeze them any closer. And this is why your liquid cannot be compressed. So in exam, right, in order to help you figure out I always like my students to draw this table to help them so they do not get confused. Now the first thing you should do is to actually draw out this.
But then you forgot to
Now, so what happens is that, okay, put here in the first column or the second column here, you can put definite shape, and then the next one you could put here definite volume. So then on the first column you will put in your three different states. You have solid, liquid, and finally gas. So in solid, you know that this two is a definite yes. Okay, your liquid is got definite volume but no definite shape, and the last one is no definite shape and no definite volume. Okay, so this chart, okay, do it up in exam very quickly, will help you actually to make sense of the question. Now when you say that you've got no definite volume, it also means that you're able to be compressed. Alright? Okay, so this helps to really summarize